SN1 versus SN2 mechanism. The difference between them. So if the types of alkyl halide in the reaction is a primary haloalkane or methyl halide, the nucleophilic substitution mechanism will be SN2 mechanism. SN2 mechanism prefer less number of alkyl group attached to the carbon which has halogen attached to it. For secondary alkyl halide, it can be SN2, it can also be SN1 mechanism. For tertiary alkyl halide or tertiary haloalkane, nucleophilic substitution mechanism is SN1 mechanism. Secondary alkyl halide undergo both SN1 and SN2 reaction. Other factors determine the mechanism. The factors to determine whether it will undergo SN1 or SN2 mechanism depends on the types of reactivity of alkyl halides. So whether it's methyl halide, primary haloalkane, secondary haloalkane, or tertiary haloalkane. So this affects their reactivity. The types affects their reactivity. Second, strength of nucleophile. Whether the nucleophile is strong or weak, it will determine that whether it undergo SN1 or SN2 mechanism depends on the strength. Finally, other information from the question. For example, rate of reaction. If it is second order reaction, it is SN2 mechanism. If it's first order reaction, it is SN1 mechanism. Products form or extract. Strength of nucleophile. In SN1 reaction, nucleophile attacks after the formation of carbocation. So first, form the carbocation. Second, the nucleophile will attack the carbocation. So strength of nucleophile has no effect on the rate of reaction because somehow the nucleophile will attack the carbocation. It doesn't matter whether it is strong or weak, it will still attack the carbocation because carbocation is electron deficient. So it will get attacked by the nucleophile. In SN2 reaction, rate determining step involves nucleophile. So remember, this is the second order reaction. Rate equal K concentration of haloalkane and concentration of nucleophile. This is the rate for SN2 reaction. So we know that nucleophile concentration affects the rate here. So the stronger the nucleophile, the higher the rate of reaction in SN2 mechanism. If we notice, the anion is stronger than its neutral compound. So OH minus is stronger nucleophile than H2O. CH3O minus is stronger nucleophile than CH3OH, and H2 minus is stronger nucleophile than NH3. Reactivity of haloalkane. So regardless SN1 or SN2 means whether it's SN1 or whether it's SN2, the rate of reaction decreases in order if you have different type of halogen here. So here we have CH3, CH2, CH2I. So all this has 3 carbon. Each compound consists of 3 carbons, but they have different types of halogen, I, B, R, C, L, F. So when going down the group from I to F, the electronegativity increase. So the reactivity of haloalkane decrease when the electronegativity increase. This is because the carbon-halogen bond is stronger from I to F. So, electronegativity increase from I to F, electronegativity increase. So, CF bond is stronger than CI bond. So, it means the bond between C and F is stronger than the bond between C and I. So it's easier to break the CI bond compared to CF bond. Reactivity of haloalkane in CH3CH2CH2I, this compound is more reactive than CH3CH2CH2F because this one is easier to form carbocation compared to this one because CF bond is strong, so it's more difficult to form carbocation. So the electronegativity, when electronegativity increase, the reactivity of haloalkane decrease. SN1 mechanism versus SN2 mechanism. This is the overview between these two mechanisms. So rate of reaction is proportional to the concentration of haloalkane only. SN1 mechanism, first order reaction. So rate, we only consider the concentration of haloalkane, but in SN2 second order reaction, rate of reaction is proportional to the concentration of both haloalkane and nucleophile, so both reactants we take account. Reactivity of Rx, the haloalkane. So it's SN1 mechanism involve the formation of carbocation. So the tertiary haloalkane is more likely to happen than secondary, but primary haloalkane and methyl halide are unlikely to happen in SN1 mechanism. For SN2 mechanism, it prefers less bulky group, less alkyl group because we want to do the back attack, the nucleophile back attack. So we prefer no R group at all or only one R group. So primary haloalkane or methyl halide is preferred in SN2 mechanism. But tertiary haloalkane is unsuitable in SN2. Tertiary haloalkane prefer SN1. Effect of nucleophile. So nucleophile strength are unimportant here because if we refer to the rate, there's no concentration of nucleophile, so the nucleophile won't be taken into account in SN1 mechanism. So we just ignore the strength of nucleophile. But in SN2 mechanism, strong nucleophile are required because it is second order reaction, so the rate involves concentration of nucleophile. So the stronger the nucleophile, the most likely of SN2 mechanism to happen. Means the reactivity of haloalkane increase if we have stronger nucleophile. The intermediate, carbocation as the intermediate. In SN2 mechanism, transition state is the intermediate. Rearrangement may occur because we have the formation of carbocation. We must select the most stable carbocation which has the most alkyl group. So we must do the rearrangement if it is available. If rearrangement is available, so we must do the rearrangement. But In SN2 mechanism, there are no formation of carbocation, so rearrangement is impossible.